Hello. Welcome back to another edition of my videos in your favorite channel, Have Fun and Learn with JP Dutta. Today we'll discuss parallel lines, then angles, how are they related, how are the values ranged from, and also rays, lines, segments and points. So let's go in. Now before going into parallel lines and transversal, let us first discuss these 3 points. Number 1, what is a point? What is the meaning of a point? Number 2, a ray. Number 3, a line. Number 4, segment, or you call line segment. Right? So we'll discuss point. What is a point? What is a ray? What is a line? And what is a line segment? First, what is a point? A point is a dot on the page or the board. Right? So a point is a dimension less quantity. What do you mean by that? That means it does not have length or breadth. That is what you mean. What do you mean by a point? Now see why points are important. If you have quantity points in the same direction, you add them, you get a ray. Right? Okay. So this was what our points are. So we discussed points, and now what is a ray? Suppose you have a point source and it goes like this on the right hand side to infinite distance. That means this ray does not have any fixed length. So we call it A, B, we call it a ray, and we write it as AB like this is the ray. Correct? Understood? Now let us see what is a line. See, we have got something like this, both extending towards infinity, this side also infinity, negative to positive infinity. So this we call a line, and we represent it as with 2 arrows like this. So AB is a line. Understood? Correct? Now we see what is a line segment. Suppose you have got a line like this, and this is say A and B. Line segment. So this particular distance has a say certain value 5 meters. So a segment has some numerical value. So here it is called, it is 5 meters. Right? So that's a segment, line segment. Right? Now we will see what are angles, how angles are formed. Angles. Oh, before I forget, and you don't forget also, please subscribe my channel, share and comment. As I try to inspire you, that will inspire me also. Right? Okay. Angles. So, suppose we have something like this. See, this is the common vertex. This is called the vertex. And it must have 2 arms. These are the 2 arms. And this is called the angle, and the value, let's say, is theta. Now theta is just a nomenclature, meaning thereby you can use x, y, z, a, b like that, or generally for angles we use theta, phi, alpha, beta. These are Greek letters. So we have use this for naming the angle. Now in angles we have got acute angle. Acute angle, right? That is something like this. You can see that it is less than 90 degree. Therefore, if it is theta, theta will be for acute angle. For acute angle. Now comes obtuse angle. So if you have something like this, you see this is more than 90 degree. So obtuse angle will have value. If this is theta, theta will be greater than 90, 180. Right? Now we have got reflex angle. Which is something like this. A, O, B. So we are talking about this angle. Okay? So reflex angle AOB is, if this is theta, then theta greater than 180 degree, less than 360 degree. So this is what you have got: acute, obtuse, reflex angle. And one more angle that we have is called a complete angle, that is angle round the point, that is 360 degree. Correct? Yeah. So we have a line like this and a line like this. See, they are parallel lines because the distance everywhere is same, right? Equal to t, equal to t. This means that parallel lines meets at infinity. That means in a way they do not meet at all. Now we talk about a transverse that cuts the parallel lines in at one place each. Correct? Now we will see how many angles are formed because of the intersection of a transversal of the two parallel lines. Have a look. So this is line M and this is line L, and the transverse is T. Now the transverse intersects M and L at these 2 points. How many angles are formed? 1, 2, 3, 4, and here 5, 6, 7, 8. So we see when a transversal intersects two parallel lines at 1 point each, 8 angles are formed. These 8 angles have different relation and names, and we will discuss them now. We look at the naming and property of all these angles, how they are related and what is their name. First, look at the angles marked with red. They are called, this and this is one pair of alternate angle, and 4 and 6 is the second pair of alternate angle. So, alternate angles are number 1, angle 3 and angle 5, number 2, angle 4, and angle 6. So they are called alternate angles. Now the property. Property of alternate angles. What is that? Alternate angles are equal. We can write so, then we can write number 1, angle 3 is equal to angle 5, and number 2, angle 4 is equal to angle 6. So what you call these are the names, and this is the property of alternate angles. Clear? So the angles marked with red, this, and these are called alternate angles. Correct? Which are all the corresponding angles. Hello. Angles, right? Now the corresponding angles we are referring to here, number 1, angle 2 and angle 6, number 2, angle 3 and angle 7, number 3, angle 8 and angle 4, and last pair is angle 5 and angle 1. So look at the figure, angle 2 and 6, one corresponding angle, angle 3, 7, another corresponding angle, angle 8, 4, another corresponding angle, and 5 and 1 are the last pair of corresponding angles. So we have got 1, 2, 3, 4 pairs of corresponding angles. 4 pairs of corresponding angles. Now we look at the property of corresponding angles. Property of corresponding angles. So that is, they are equal. So we can write number 1, angle 2 is equal to angle 6. Number 2, angle 3 is equal to angle 7. Number 3, angle 8 is equal to angle 4. And number 5, angle 5 is equal to angle 1. Right? So properties, these are the properties. Right? So we get 4 pairs of corresponding angles, and the corresponding angles, as I have mentioned, they are equal. Now we talk about interior angles on the same side of the transverse. Interior angles on the same side of the transverse. The transverse. So what are they? Look at so this and this one, angle 3 and angle 6 are called interior angles on the same side of the transversal. That is number 1. Number 1, angle 3 and angle 6. The second pair is angle 4 and angle 5. The second pair is angle 4 and angle 5. Now this interior angle on the same side of the transversal has got 3 other names. The same angles are called in 3 other different ways. They are number 1, consecutive angles. Number 2, co-interior angles. Number 3, my favorite, allied angles. So what we understand that interior angles on the same side of the transversal are these 3 and 6 and 4 and 5, and they are also known as consecutive angles, co-interior angles and allied angles. Oh, by the way, before I forget, I try to inspire you with my videos so that you get more interest in mathematics. So please subscribe so that it also inspires you. So please subscribe, comment and share. Okay. Now to the properties of interior angles on the same side of the transversal. What are the properties? Property of allied angles. I call them allied angles. So number 1, angle 3 plus angle 6 will add up to 180 degree. Similarly, angle 5 and angle 4 will also add up to 180 degree because both of them are interior angles on the same side of the transversal, or you can name any of these 3. If any doubt exists, let me know in the comment box. So that will be all for today. Till next video, which comes up tomorrow. But by the way, let's have a small quiz. Meaning thereby, if you have seen the full video in a certain part, okay, let's be specific. In angles, I have glaringly and loudly missed out a particular angle. What is that angle? Can you tell me? Those who comment, to send this answer to my comment box, the first 3 I'll mention with thanks in my next video on next Monday. Understood? But no username please. Your name, school, location, class, they must be included. Thank you for watching and keep on subscribing.